All right. So now that we have everything set up, let's go ahead and start building our first pipeline. So the first thing that we want to do before we actually start pushing anything is to determine what our pipelines should actually look like. So really see what really is the best fit for our team's needs. Now, our product manager asked us to go ahead and just get a pipeline up and running. And so before we jump into it, let's just look through some of the basic aspects of what a pipeline definition looks like within GitLab. So let's start off with defining the different scripts that can be run within a job. Generally speaking, we have three different aspects here. We have the before script, the actual script, and then the after script. Now, if we look at the actual script here, so just called script, this is the script that represents the main logic of our job in here. And the thing with the script command in here is that the exit code of the script defines if the job is considered successful or not. We also have a before script, which, as the name suggests, runs before the script command here on the left-hand side. And oftentimes this can be leveraged to, for example, run some setup scripts, some things to set up the environment that the script actually should run in. And very often, because we see that connection between before script and script, we also have the fact that both the actual script and the before script run in the same shell. Now, a big difference is the after script, which, as the name suggests, again, runs after the before script and the script, and runs in a completely different shell. Also important to note is that the return code of the after script does not impact whether the job is considered successful or not. Awesome. So now we've looked at the order in which scripts run within a job. And now let's go ahead and take a look at the order in which jobs run themselves. So the execution order in here. Now, by default, what we have is, generally speaking, jobs will only run after all the jobs in the previous stage have been completed. So in this case, for example, we have a test job in a test stage. And the test job, again, will only run before all the jobs in the build stage are completed. So in our case, that's just one job. But if we had multiple jobs in here, again, this would wait until everything prior is complete. And now one final aspect that's really important to remember here is, or to address here, is the GitLab runners. And they're used to really determine or really used to run the jobs of the pipeline themselves. So you can really see like the different jobs that should be run for the different runners. We can define, for example, within the different jobs tags, so specify which specific runner should be leveraged in order to run a specific job. And generally speaking, although these different jobs can run for multiple minutes within a runner, usually the time that a runner needs in order to pick up a job is within 5 seconds. One thing to remember also that's really dependent on what your setup is, but you could use some additional features to optimize your setup, such as auto scaling, for example, when runners are hosted on AWS, to make sure that you always have the correct amount of runners to meet your needs. And now one thing that's really important is the different ways in which you can execute GitLab runner jobs. So the first one is shell. And so as the name suggests, they basically run commands as if they were written in a terminal command prompt PowerShell. We also have Docker, which executes within a Docker image. And in our experience, this is the most commonly used. We also have the option to leverage Docker machine, which basically scales up runner with any executor on demand. And we very often see this in cloud deployments. And finally, Kubernetes, which runs as a pod within a Kubernetes cluster and also allows for auto scaling in here. All right. So now that we've looked at some of the basics, let's go and get hands-on with today's workshop. So what you should ideally see is something similar to this. So our test group in here, again, the text on the right-hand side can change, and we have that one project in here. I called it workshop project, but it's basically that Tanuki racing project. Now, as mentioned previously, we will follow along with instructions, and where you can find those instructions are by clicking on the project itself. And for future reference, click on courses, workshops, and CICD. And here you will be able to see all the different instructions. For today, feel free to open those instructions and have them open on the side if you want to follow along. I will have my screen split here. So on the right-hand side, I will always have my instructions. On the left-hand side, I'll actually be showing you how we apply these instructions, so the actual workshop process itself. All right. So with that, let's go ahead and get started. So as we can see here, step one, importing basic CI/CD application. This is actually what we've previously done. So all this talks about is really forking in our Tanuki racing project in here and removing that fork relationship. So what we can do next is get going with creating our first very simple pipeline. Now, the first thing we do is go to our workshop project and then open the GitLab CI YAML file. So this will be, in my case, the workshop project, depending on how you named it. When we did the fork, it might be Tanuki Racing, it might be workshop project. Just go ahead and click on that. And then from there, again, we're looking for the GitLab CI YAML file in here. Let's go ahead and click on that. Awesome. So we can see that we already have a very simple pipeline defined, and we have two stages in here. We have the build and the test stage. So as we can see here, lines 14, 15, and 16 defines the different stages, build and test in this case. And we can see that the build job uses the before script, and after script keywords. So if we look here, line 22, we have the before script, line 25, the script, and line 27, the after script. We look at the test job. We want to now go ahead and use the after script keyword to echo out that the test has been completed. And so to do this, basically what we want to do is edit it in our pipeline editor. Now, there are a couple ways of going ahead and doing this. Easiest way is just by clicking the edit button on the top here, and then click on edit in pipeline editor. So as suggested here, we're going to add a after script to the test job. So we'll scroll down, find our test job on line 30. Then we'll go ahead and copy paste this in here. Go ahead and copy this to the clipboard. And then paste that in here. There we go. Making sure that we have it tabbed in correctly in here. And so with that, our test job should look something like this. So basically the same thing here, just we have the after script in here, and sure enough, that's the case. Great. So let's go ahead and continue with 4. Once you've added the code, we can go ahead and now commit these changes. So let's go ahead and do that. Do that by clicking the commit changes button. And now we want to go ahead and continue on with step 5. To view the job, use the left-hand navigation and check out the pipelines. So easiest way to do this is just go over to the left-hand side here, go to build. Then when you hover over this, you'll see the pipelines submenu item. And sure enough, we can see this pipeline here is running. And the easiest way to get a look at this is just by clicking the ID in here. And so we can see we have a build job and a test job in here. The build job is currently running, and as previously mentioned, the test job is waiting for all the jobs in the previous stage to complete before it itself can go ahead and run. Now, we can go ahead in here too into the test job if we want to. And once this starts running, we'll be able to see the logs, and as in step 6, we'll see the message that we echoed out. Now, while we wait for this, we can go ahead and just take a look at step 3, which is an exciting new feature that GitLab offers, which is GitLab Duo. So GitLab Duo chat, in this case, is something that we can leverage in order to really get some information around GitLab features and functionalities. So the easiest way to access that is by going to the bottom left, clicking on Help, going to GitLab Duo Chat, and then we can just copy paste, for example, this question, like what CICD keywords can I use in GitLab? Or anything else related to GitLab. So this could be anything from asking questions around documentation, how to approach this, is this and this possible, and so on. Sure enough, we can see here it comes up with relevant information here in our case. Great. So throughout the workshop, if you do get stuck, if you do have questions, also feel free to try out GitLab Duo Chat and see if maybe you can just get a quick and easy answer leveraging our AI-powered chatbot. I'll go ahead and close this. And we can see here in the background that our job is running at the moment. And hopefully should be done here fairly soon. Great. So sure enough, for me, it's on line 108, or rather on 109, we can actually see the output. Our racetrack has been tested. Awesome. And so with that, we're already done with the first section. Now, let's go ahead. We went through quite a bit, so let's just take a 5-minute major pit stop in here. And yeah, see you guys in 5 minutes. All right. Right. So I think that was 5 minutes. Get going and continue on with the workshop. So with that, let's look into the next section. So here we're looking at job execution order and directed acyclic graphs. All right. So as mentioned, we just started off and created a very simple pipeline setup, and everyone loves it. However, now we're asked if we could somehow speed things up a bit. So what we're going to do here is go ahead and look into this, create a pipeline with different execution orders, as well as creating large DAGs. Now, before we jump into this, let's just talk about a couple of things in terms of adjusting the execution order for pipeline efficiency. So previously mentioned, jobs in the test stage execute after all jobs in the build stage are completed. Now, assume we want to go ahead and add a new test called super fast test, which really doesn't need the results of the build stage in here, and it could theoretically be run in parallel. However, we still want to keep that within the test stage in here. And so that's kind of what we're going for next. So we can go ahead and leverage the needs keyword for this. Needs allows us to specify which specific jobs we need to run beforehand in order to run this specific job. And this is independent of the stage that the job is actually in. Now, if we leave the needs keyword empty, so if we define it as an empty array in here, all that means is that this job doesn't require any prior jobs at all and can just go ahead and kick off right away. Now, we can leverage needs to really create highly custom optimized pipelines specific to our needs. However, with the added complexities comes the potential the difficulty of actually understanding how these pipelines function purely by looking at the YAML file. And so this is where GitLab adds DAG in order to really allow us to visualize and understand everything that's going on quickly and easily. One thing to also mention is that you can actually use the needs keyword within the same stage, which previously was not possible and only doable between different stages. This can be useful to make your pipelines more efficient, implicitly configuring the execution order, resulting in faster writes. Now, by improving the efficiency of our pipelines, we directly affect the cycle time. And now all of this is available in GitLab 14.2 and beyond. Awesome. So next, let's go ahead and take a look at what this actually looks like. So what we'll do in the instruction page is first go back. So one way of doing that is just as we saw here, clicking the CICD directory in here, or by clicking the back button. And next we'll look at section 2 here. Now let's go ahead with step 1, execution order. So if we're coming from the last track, we should still be on the pipeline page. However, or if you did navigate away from this, just go back to your project, use the left menu items over here. So go under build and then under pipelines, just showing you what that looks like. So build pipelines and then heading back to that pipeline that we just saw. Again, easiest way to access this is just by clicking the number, its unique ID in here. Now, part 2 here, we can see that our pipeline ran sequentially, right? So build and the test jobs. But what if we wanted these 2 jobs to run in parallel? So in this case, we would need the needs keyword. So let's go ahead and play around with this. And again, just like last time, we'll head back to our GitLab CI YAML file to make appropriate changes. So to do this, again, we'll go back to the build menu item, and then going to pipeline editor. And now, at the moment, as stated here, we only have the test job running, and this is running during the test stage. But we want to add a new job called super fast test. And so what we'll do is we'll scroll down to the definition of our test job in here. We'll just go ahead and copy the job definition of our super fast test. Next, we'll go to our pipeline definition and paste this directly under test. So now we can go ahead with step 4. Let's see, now that we have the 2 jobs, we also want to modify the execution order. Add the following line to the end of the test code block. So let's go ahead and do that as well. So making sure that the test also has needs defined as an empty array in here. So again, at the end of the test jobs, making sure to have this in the correct format in here. And we can see our test job should look something like this. So again, the only change that we really made here was adding needs. Now we can continue with 5, committing our changes, and then checking out our pipeline. So again, let's just go back to our editor and click the commit changes button. Now, again, we can see our changes have been successfully committed. And we want to take a look at that pipeline. So we go again on the left-hand side to build and go to pipelines. Let's go ahead and take a look at this. Awesome. So let's see here. As you watch, you can see the 2 jobs run in parallel. So sure enough, we can actually see that we have all the jobs here kicking off, build, because it was the first job in here generally in the first stage. And for test and super fast test, we've defined needs to be an empty array. So defining that there are no prior requirements. And so these can be kicked off at the same time, again, making sure that all of these jobs now run in parallel, improving our efficiency. Great. Now, the other aspect here is in step 2 here, right? So really visualizing those relationships between the different stages and the different jobs. Let's go ahead and start off with 1. So if we have many stages and relationships between the jobs that we would want to run as soon as possible, we can accomplish this using DAG. Use the left-hand navigation menu and click to CICD and editor, right? So similar to before, all we're going to do is edit our pipeline definition again. So we'll click on our editor. Ooh, apologies. I have the element pinned in here. So again, clicking on build and then going to pipeline editor. And now the first thing that we're going to do is we are going to update the stages section here. And we will go ahead and add the deploy stage. Oh, nope. Let's see here. We will want to add the array stage in here. So basically what we want is this definition in here. So stages, build, and test, which are the same. And then we will want the race part in here. So it should look something like this. And now we are going to add a lot of additional jobs in here, and we'll add them under our super fast test job. Easiest way to do this is by heading again to this instruction page and just copy pasting this. So again, copying this big piece of code here and pasting it underneath our super fast test job. And now what we can go ahead and do is click on the Visualize tab, and we can really see how complex these many stages are in here. So the Visualize tab is up on top. And sure enough, we can see a bunch of different aspects here connected with each other and all these various different relationships that we have and dependencies that we have in here. So again, here allows us to visualize. And what we want to do next is go back to edit and actually commit these changes in here. So again, clicking the big blue commit changes button. Now let's go ahead and take another look at our pipeline. So in this case, again, going to the build section and then going to pipelines and clicking on the latest pipeline that is running in here. Great. So let's see here. We can see the most recent kicked off pipeline. We can watch all our cars race to be the first in path. So yeah, you can see here that we have the different build jobs. They're running in parallel right here, and we can basically see we have test car C already starting. Some of the other jobs haven't started yet. So yeah, really that visualization in here as well. Okay. So with that, let's keep going. This is going to take some time here. We can come back to this in the future. Let's go ahead and go to the next section in here. Caching rules and failures. So we've managed to take a look at the pipeline, figure out that we can leverage the needs keyword to add efficiency here within our pipelines. And next, what we want to take a look at is making our pipelines even faster and more resilient. So to do this, we'll go ahead and take a look at GitLab's ability to allow caching through runners and S3s. So let's go ahead and take a look at some of the basics behind caching and the cache execution order. So everything starts with the pipeline. This will go ahead and trigger our first job, so job A in here, and we'll have our before script run, our script run, and then our after script run. So next, the cache runs and the Mender directory is zipped into a cache.zip file. And this file is then saved in the directory depending on the runner settings and the cache key. Then we have job B running. And in this case, before we run the before script, the script, and so on, the pipeline or the cache is then extracted if it is found in this case. And then finally, the pipeline finishes. So now that we understand how it works, you might be asking yourself, well, what's the benefit? So first of all, you can share downloaded content between jobs and even across branches or code dependencies. This means that you can save on that download time for each job that leverages the cache. Now, if we don't need to re-download everything, that means that our pipeline can run significantly faster. Another thing that could benefit us is the ability for us to allow jobs to fail. So making sure that subsequent jobs don't fail as well. Now, this can be done with the allow failure keyword that does exactly that. We will see that the job has failed. However, our pipeline isn't broken, but continues running in these cases. So all we'll see here, for example, if a pipeline has failed, but we do have allow failure, is this exclamation point in here. Another important aspect is rules, which allow us to define conditions where we either entirely skip jobs, and by doing so, we basically make our process more efficient. So here, as mentioned, we can define conditions where jobs should run or where they should not run. And ways in which we can define if they should not run is if any of the rules that we've defined basically don't evaluate to true. So if none of our conditions are met, for example, here on the right-hand side, we can see some if statements and if conditions. So if none of the rules defined are met, if a rule evaluates to true, but we have a clause in there that defines how it then should be run. So in this case, never. Again, that means that that job will not run. Or if we have no rules defined at all, but we leverage the when never clause. And so that basically means that our job should run never. And now these rules are highly customizable. So we can use different clauses, operators, job attributes, other when options to really customize this and make sure that we're only running jobs when we need to. And otherwise we leave them out to improve our efficiency. Another important thing to note is that GitLab comes with a bunch of default pipeline variables that allow you to quickly and easily access information such as pipeline source, branch name, and much more, which you can use within these rules. Now, we've addressed when in combination with rules. However, you can use when without rules as well. So for example, if you wanted to, you could say define a job as manual. So you basically only define when manual. So this job would, for example, wait for someone to click the play button. So in our example down here, we can see that there is a deploy job. However, this is not automatically running. Someone would need to, as mentioned, come in here and click this button. Now, here are another couple rules or rules examples of how rules can be leveraged. And so in this first example, we can see here we have multiple rules defined. And this will run if the source is a merge request event, or from a scheduled pipeline in here. So this really is more of an or statement. So if one of these two is true, then the job will execute. We also have the option to add something in here as well. So defining not just when, for example, never, so never run this job, or always run this job, or run this manually. We also have the option to define delays in jobs. So in this case, if the commit branch was master, but we defined everything as follows. So when is delayed, that would mean that based on the start in keyword, this job would kick off, but only delayed 3 hours, or delayed by 3 hours. Yeah. Now, another example, you can use multiple rules, and you can define multiple wins for each one of these rules. So, for example, here we see various different rules, each with their own win. And basically what happens is the evaluation goes from beginning to end, and once something is matched, it will basically skip the rest. Exactly. And one thing that we can see here too is the when on success keyword that only executes if all previous jobs are successful in here as well. All right. And the last example of rules here is leveraging the changes keyword, which can also really be beneficial to add efficiency in here. So what changes basically does is it looks at specific files that were changed and uses that as a condition. So if a certain file was changed or wasn't changed, this rule will kick in place. So for example, in our case, if the variable var is equal to string, and there was a change in the Docker file or in any of the files under Docker scripts, then this job should run. And because we've defined the when keyword in here, this job will be run manually. Now, before we go on to the next hands-on section, just something to address in terms of the order in which variables are processed within GitLab. And we've mentioned a couple of them, right? So for example, the commit branch, the source. And again, really important is to determine well which variable is actually leveraged here. And so in terms of priority, we have the CICD pipeline trigger variables. So these can be variables that are defined specific to this run. So for example, in the UI or via the API. Then we have in order project level variables, group level variables, and instance level variables, which again, depending, for example, if you're running a pipeline within a project and it's part of a group, well, it inherits these variables. Same goes for the instance. Next, we have values that are inherited from previous jobs in the previous stages. So for example, with our build and test pipeline that we saw earlier, our test pipeline would inherit something, for example, from our build job. And then we have global variables, deployment variables, and finally, predefined environment variables just defined from GitLab themselves. So with that, let's try this out. So just like last time, what we're going to do is go to the current instructions. And in our case, again, one easy way is just by clicking on CICD up here on the top in the nav bar. And then going to section 3, caching rules and failures. Now, what we're going to do here is follow along with step 1. And the first part of this is we need to reset our existing pipeline from the previous track and remove all DAG jobs. So what we're going to do here is make sure that we're in our workshop project, go back to our editor, and make adjustments to our YAML file. So in our case, if we've left, if we're in the position that we were after finishing our last section, just going to go back to the, let's see here, going under builds, going to pipeline editor. And then we can go on to the second part here, which is removing code that matches the code below. Everything else can stay. So everything from build car A down to race car F can be deleted. So if we go ahead and see, sure enough, we have build car A up here. Scroll all the way down to race car F. We'll go ahead and delete this. So we should be left again with our build job, our test job, and our super fast job, our super fast test job. And what we'll also need to do is update the stages because we removed a lot of jobs that had to do with that race section. So now it really is just the build and test stage in here. Now I've done this manually, but we also have exact definition of what this should look like in here. So feel free to also just copy paste this over if you need to. All right, awesome. So now we can go ahead and actually start applying some of the rules that we just talked about. Let's start off with a very basic one for our test job. So all we're going to do is we're going to say this job should only be running if we're merging anything into our main branch. And so in order to do that, we can copy paste this section here. So rules, and then as we can see here, if the commit branch equals main. So we go to our test stage. We'll go ahead and add that in here. Again, making sure that we format this correctly. Now, we're not going to go ahead and commit this yet because we also want to add a couple of other aspects in here. So that would be part of step 2, pipeline speed with caching. So we can see here, if we start off with 1, our committing from our last change did take quite some time to run. Our next few pipelines will build off of our current configuration. So we'll go ahead and add some caching for the node modules so that they don't have to be pulled the next time. So in order to do this, what we're going to go ahead and do is add this following piece of code under the image definition. Let's go ahead and copy this. We'll go back to our pipeline definition, scroll all the way to the top where we see our image definition. And then line 2, let's just go ahead and copy paste that in there. Great. So now that this code is added and the shared runners will now go ahead and cache this information in S3s for us. So we can pull them the next time. Okay, and then before committing, we will go ahead and finish up with the last step. This has to do with allowing for failure. So what we're going to do in the first step is actually define an exit code for the super fast test of 1, which will make it fail. So we'll go to the super fast test, copy the exit code here. What we're going to do is add that to our script. So it should look like something like this. Great. Now, if we want to allow failure on a rule that we had set, so let's go ahead and play around with our super fast test job. Let's go and change the rules in here. So similar to what we had with the test job itself, we're first checking if the commit branch is equal to main, but we're also making sure that we're allowing failure here. So as we just added in here, exit 1 will cause this to fail, but because we have allow failure, that won't completely stop our pipeline. Great. And so if you did add a typo here or weren't able to keep up with the instructions, you can always just go ahead and copy paste what we see over here and paste that in here. All right. And now we're ready to go ahead and commit our changes. Let's go ahead and do that by, again, clicking the commit changes button and heading back to our pipeline. So again, going under build and then under pipeline. Now we'll go back to our latest pipeline. Again, the easiest way to do that is by clicking its ID. Great. All right, so that's part of part 4 here. So we've committed the changes. We are looking at the pipeline. In the pipeline view, as the job runs, click on each of them to see how our add rules failure have changed the output. So we should see that our should be super fast test job fails with a warning, but the pipeline succeeds. So we will see that here in a second, hopefully. Unless I made a mistake. I believe I made a mistake. I didn't add the exit code in here. So in an ideal world, you did that and you did that correctly. So you should see that failure in there. So that should, as previously indicated, show up as an exclamation point not this check mark in here. Great. So with that, again, unfortunately, I seem to have not committed that change, but hopefully you have. You'll see that allow failure here has run, and yeah, you'll see the changes of rules and allow failure in here. So with that, I think it's time for one last pit stop before I believe next up I hand it over to you, Olivier.
I believe so, yeah.
All right, so I'll stop sharing and give it to you.
Done. Well, all right. Give me 5 seconds to share my screen.
So yeah, just as an FYI, we're still having a break. And at quarter past, I think we can go ahead and continue going.
You should be seeing my screen, right?
Yep.
Wonderful. All right, here we are. Let me hide that floating things. And let's move on to the fourth lab. We are going to talk about templates and artifacts. And maybe since we are changing your leader, say, maybe we could start with a small poll, just to know how you're feeling so far. And so I can adjust the pace if needed. If you want to go too faster, slower, whatever. So better view of how things are going for you. And on top of that, it leaves you a couple of more seconds to finish with the lab 3 if needed. All right. So in the vast majority, people are saying it's just right. A couple of too fast, a couple of too slow, but that's the way things are going. Seems pretty normal to have some are in advance, some are struggling a little bit more. And no one is lost. That's a good point. Good job, Ted. You haven't lost anybody. Rats.
Happy to hear it.
Yeah. Okay, let's go. Back here. All right. Templates and artifact. So obviously our execs are very happy of what they have seen so far with the pipeline that you have implemented, and the race is going very smoothly. So everyone is happy. But we are reaching a point where we figure out that security has been forgotten so far. And it seems to be like a problem. Well, let's do and add some security in our stages so we can feel more secure, basically, more comfortable, and we can move forward knowing that GitLab has our back and that we are not going to raise any threat to anything. So what are we going to do now? We're going to work on the SAST part of the security. SAST means static analysis security testing. We also have the DAST for the dynamic security testing. And basically, this SAST is a way to look at your code. It reads your code and finds if there is any issue, any problems in the code that could be a threat to your assets, to your customers, to your whatever, your production or anything that is valuable to you. All right. So let's start with the right part of the screen where we see what is going to happen in your pipeline. Basically, we're going to commit things, and from there, GitLab CI will trigger the jobs that you have defined, obviously, and it will run a couple of security scans where the developers can dismiss or accept them or fix them, or maybe if he doesn't want or she doesn't want to fix them right now, can create an issue to handle that later. And then we will have the same thing from the security team. So they know what's in production, they know what are the threats currently being deployed, and they know how to, and they can triage them, so we know which ones are the most important and the most which one of the highest priority to be fixed. All right. The idea here really, and I love that picture because this is really it. We are shifting left security with GitLab. What does that mean? It means that we are going to identify the threats earlier, as soon as the developer commits them. Actually, it means that you are going to test things as soon as it's being developed, while your developer is fully aware of what he's doing or what she's doing. and not once you have landed. No one would say, okay, we're going to the moon and we'll check security once we will be there. We'll check if we have oxygen and all these things. And this is what you are doing basically in the software industry when you are testing in production or right before production. And this is what we don't want to do with GitLab. We just want to shift left and handle security earlier so we can land safely on the moon or in your production environments. And so how are we going to include these security tests in your pipeline? This is as simple as including writing down 2 lines in your pipeline. The 2 lines that you see here. We start with an include keyword and then the template, and we are going to use the template job SAST GitLab, which is provided by us basically. So we will have all these security scanners running for you on your code, so you feel secure and safe to move forward and deploy to whatever environment you want to deploy your source code. And I've talked about templates. I said it's as easy as including a template, but what is a template? Well, basically, a template is a way to share or consume, depending on where you are, CI/CD capabilities, right? You are writing things that are valuable and you want to share them with other teams, you are sharing a template, and other teams will consume a template, of course. And since we use GitLab at GitLab, since we do everything in GitLab here internally to develop GitLab, obviously, we are also developing templates. And since we are open source, we are sharing them. So this is also the way that we, our engineers, are sharing their templates to you, so you can get the best out of GitLab with writing only 1 line of code and having all your back secured. What templates are not? Well, they are not magic. There is no magic here. This is simply CICD YAML files, the one that you have already written. They might be templates. You are just going to write some of them and see how they work, but this is basically the same thing. We didn't want to include some additional complexity, adding some new language or whatever, or some new patterns. We are just doing templates and sharing them. This is GitLab CICD YAML file, standard file. And the templates so are executed in your pipeline, including the statement. You can see it basically as some kind of copy paste of your template in your pipeline, but dynamically done for you by GitLab. And I say sort of because we are able to override things in the templates. We will see that together. All right. So let's move forward and see what we can do and how we can include these templates. We have discovered that there are basically 4 types of needs here. The first one is the one that I've just talked about. Reusing templates that our engineering are developing and are sharing for you. This is the include template keyword, the one that you have seen in the previous slide and the one that you see in the top left corner here. All right, you can also reuse your own templates or the one that your colleagues are developing in their own project. So this is the include file, where you target a project and a file, or you can target a file inside your own project directly. So this is the include local. And then the last one is to include a remote template, okay, something that is shared by a public company. It could be, you can target our own templates using this include remote, but it's way easier to use the include template. But anything that is public can be accessed with the include remote, as long as you are targeting the file, the YAML file. All right, and as I said a couple of minutes ago, these templates can be customized. Okay, this is not purely copy paste. You can overwrite anything in your template. So meaning you have jobs defined, you have variables defined, and as long as you rewrite the parts of the job or the variable that you want to overwrite, it will be overridden directly. Meaning that if there is a variable defined in your template and you rewrite that same variable in your pipeline, then the variable that you have written in your pipeline will have the precedence. If you have a job with a given script and you rewrite this script in your pipeline, the template script will be overwritten. Okay, this is not an addition of both. This is really a replacement but what you have written so far. So basically, Ted showed you how to define rules, and maybe you will find some templates with rules, very strict rules that are preventing the job to run in many cases. And you just want to override these rules and say rules when on success. For example, I have seen a question regarding that. You can simply define rules on success. And so this way, you will ensure that the job is always running, or on success or always running. All right, so this is the way you can customize things and customize the behavior of your template. Okay, and so basically you want to know what the template is and you want to understand the content of the template if you want to customize it. So for our templates, the one that we provide, maybe my colleagues can share in the chat the link to the templates page in our documentation, which then provide you a link to all our templates. As I say, they are open source, so you can freely read them, see all the variables and everything that they do. And you will see there that we have a set of way to customize them. And basically for the Docker images, for example, we can define reuse and override the variables, the one that are shown here, to define a prefix or exclude some analyzers and so on and so forth. All right, so these are the way you can customize the template that we are providing to you. And so on the left part, you see the documentation, and on the right part, you see the actual code, the code of our template. So these are the different variables, and the way you can override them is simply rewriting them in your main job, which includes the template. All right. So yeah, transition directly. We're going to transition directly to the artifact, because the security templates that we are going to use today and that we advise you to use in your daily life are outputting results. All right, basically we are running a set of scanners, of analyzers, and they will provide results in a file, and we are going to make this file available. So sorry about that. So it can be understood by the GitLab UI. It can be reused to update the different security pieces that we show in the in our UI, the widget, and so on and so forth on the security page. And so it might be we are going to use the artifacts for that, and you can use the artifact for anything that you want to share publicly. I say publicly, you can define some rules to protect your artifacts, but by default, artifacts can be seen in your pipelines or in your jobs pages, and you can download from there. So anyone who can access your project, basically, and your pipelines will be able to download by default your artifacts. So if you are writing anything private, any secret in your artifacts and outputting this artifact, making them available, then you may be at risk and you would prefer to use cache basically for this. And so where are you able to download these artifacts? Well, basically in many places in your build section of the GitLab UI, in the left-hand sidebar, you have a build section, and there you have the pipelines where you can download the artifacts. You can dig inside a pipeline and find a job and download the artifacts from this job. You also have a job section in the build section where you can find all your artifacts, and you also have a artifact page where once again you can find everything that you need that has been output as an artifact. All right. One of the things to note here is that the artifacts are written on disk. obviously. So they take place on that disk. And what you may want to do is to set an expiration on these artifacts and say, okay, this artifact will expire in 1 hour. This is what we see in the example here. You can set any time frame that you want. And from there, if you run 10 times your pipelines, you will keep only the last one once the expiration date has passed. All right. And if you want to keep the artifacts for a specific job, you can always click on the keep button to keep them as long as you want. All right. So now that you have the theory and you have understood what a template is and what an artifact is, let's move on to the templates and artifact section and the instructions. Ideally, you should continue seeing my screen. I will do exactly like Ted with the instruction in the right part. I will enlarge them a little bit. Okay, should be good. So here we are. Let's see and let's go through the different steps. I will leave you to the steps. Go ahead, read them, and we'll go through them together in a couple of minutes. Just to explain you what we're going to do, we are going to find what has failed in the previous pipeline that you have triggered with TED. You have added that exit 1 instruction. So normally your pipeline has failed. This is what was expected. And then we are going to include in the second step, we're going to include the templates that I was just talking about. And we will see what are the results. We'll tweak a little bit the template. All right, to define what is included, when does it run, and finally, we will store the artifacts. Please be aware that before committing the code from one step to the other one, we're going to go through all of these steps because each pipeline may take a little bit of time to run. So we want to go through all of the steps before committing and running the pipeline. All right, please enjoy. All right, I'm seeing many thumbs up here. So I'll start to go through the steps with you. So the ones who have not finished yet, please feel free to follow up with me. So the first instruction is to basically understand what caused the previous build to fail. And for this, we are going to use the AI. As I said earlier, sorry, in the chat, AI is everywhere in GitLab, basically, and we have included it not only for code suggestion, which is a commodity, basically generating code, but really everywhere. And you will see that we can use it, for example, to identify why a pipeline failed. So I'm here in my pipeline view, all right, and I see that I've got an issue here on a specific job. So I'm gonna just click on that job, the super fast test. And I have tons of, well, tens. I have tens of logs in my log. Sometimes, and I'm pretty sure you've already seen that, logs which are slightly longer, not only 30 rows, but 3,000 or something like this. And you need to find what is the problem here. So what we're going to do here is to leverage the AI, clicking on that button, root cause analysis. And here I'm going to ask generate a root cause analysis. And the AI will read the logs for me, understand them, and say, okay, here is what caused the error. You have that specific instructions, and here is the one that should fix your problem. All right, so with a very basic script here, the solution might seem very obvious, but sometimes you have tons of npm or even whatever instructions, and something is fitting deep in your logs, and the root cause analysis will be so helpful and will help you save a lot of time. All right, so now that we know how to fix this, we are good to go, and we can move forward to step 2. So what is step 2? We're going to back to edit our pipeline again. So I will just go here to my pipeline editor, right, on the left-hand bar. And from there, I will include a template. This is what we have seen earlier today. So let's copy that and include it right after my cache, for example. Okay, I'm including here the template. And as soon as I'm doing this, you see here something appears on the left-hand side. You can hide it if you want with that little tree button. But here I can see all the templates, everything that has been included. So I can go and have a clear view of what is being included. This is the way you will understand your templates and how you can overwrite the variables, the rules, whatever. Okay, actually, this one is a meta template, which simply includes another one. All right, no problem. Let's go and see the other one. As you can see, the UI in GitLab understands the chain of pipeline inclusions. And so it has seen the first one, but it has also seen the second one. So if I'm clicking here, I will see all the things that are defined in this specific template. The set of variables we have already seen in the slides earlier. All right, and the different stages here. And as you can see, I've got rules when never here. This is exactly what I was talking about a couple of minutes ago. And these rules will be overridden. It's overridden actually by different other jobs which are extended this one. And it can be overridden as well in the main pipeline. Okay, so we see a couple of things. We see that the SAST is running in the stage test, and we will override that. Okay, we've got Bandit, Brakeman, ESLint, FlowFinder. All of these are dedicated to specific languages and things like this. So GoSec basically runs only on Go project, and the ESLint for ES project, and so on and so forth, right? So you see all the rules that you have defining and the different scanners that we can trigger, and or you can disable as well the scans if you don't want them. Simply say SAST disable, for example, and then your job will never run. Okay, so once you have properly understood the templates, you're fine with them, and we'll move forward and use them. Okay, we have gone through step 3 and 4 here. As I said, you can see templates as a kind of copy and paste. So if you want to see the full configuration, you can click here on the tab full configuration and see exactly everything that will be included in your pipeline and that will run in your own environment. All right, so this is a way to see the to have a global picture. And here for me, you really see the importance and the power of templates. This view for me is unreadable. I can't understand what's going on here on line 255. I can't maintain that. It's way too hard. There are too many things. And so this is where I'm leveraging the power of templates, sorry. And I'm just adding pieces of code like I would do with a code with classes and function and so on and so forth. I'm breaking things into small pieces that I can understand easily. And it makes the things really much easier for me. All right. Feel free to use the other tabs if you want to have another view of your templates and your pipeline. Okay. And now we are going to add a couple of other templates. I will just copy that section and paste it here. Feel free to leave the security master or meta template that was here. It's not a problem. And I'm just including a set of templates from GitLab, from my colleagues here. And I will add a specific stage, the security stage here. So let's update that. Oops. Let's update that. All right. So I have a new stage. I can have a stage with any job running, but what I will do is I will add some jobs to that stage. And now, so this is the step 3. And what I will do is I will override the SAST job that we have just seen together in the minutes ago. And I will set it to run in the stage security. Just copy that and paste that here as well. So here with that, I'm overriding only the stage and the needs instructions, and everything else that has been defined in that job in my templates will stay as it's defined in the templates. Okay, so this is really a way to override only pieces of my template and have them matching my exact needs. All right, so I don't want them to run anymore in the test stage, but in the security stage. All right. And before committing, as I said, I'm gonna move on to the artifacts part. So we can trigger only one pipeline and it will go faster for us. So now that we have added some security things and things like this, we're going to add the artifacts on the build job. All right, this is that section. I will just output the gemlock file. All right, this is a Ruby project. So this is your POM XML or your JSON, package JSON in NPM or whatever. This is the equivalent. Just adding this here, artifacts up. The spaces are very important in YAML. As you all know, as you may know, sorry, YAML is very strict on the indentation. So I must have artifacts slightly two spaces after the build, the name of my stage actually, of my job, sorry. All right, so I'm giving you the path and I'm saying it will expire in 1 hour. I don't want to keep it longer than that. And everything seems okay so far. So I will just commit section 4. It's 4, yeah, right. Section 4, security templates and artifacts. Go on, I'm committing. And from there, it will trigger a new pipeline. You can access it from there. The pipeline editor is checking the status of the pipeline. You can access it from there, the view pipeline, or as usual from your left-hand bar, you can go here and see the pipelines and just click on the last one, either its number or the status, whatever. It brings you to the pipeline view. And here you can see that I've added a new stage, which is security here. I have a needs, which is empty, so I don't need to wait for this test stage to end before triggering my security stage, where all the jobs defined here. All right. And I can see that all my security steps have run here. So I've got everything that is secured for me. All right. And one of the things that we want to do here is to check the artifacts. So let's go here. What kind of instruction are we given here? Okay, let's go to the pipeline here. And when a pipeline is generating artifacts, here on the right of your pipeline, you can see the list of artifacts that has been generated so far and that has been made available so far. And so I can click on any of them. The build is not yet finished, so the build artifact, build archive is not yet available. But I can see here all the SAST artifacts. And if I go to a previous job, I run it earlier, maybe that one, yeah. I ran it earlier today. So here you can see the code quality or build up somewhere. The build up should be there. Oh no, I haven't added the build up. Well, anyway, you just can click here anywhere and see your build archive job, okay, and artifact 3. And if you click on it, it will download it. It's a zip. You can open it and do whatever you want to check your artifacts. All right. As I said, there are many other ways to access the artifacts. Just go through the different options here in your build sections, from the pipeline, from the jobs, from the artifacts. Pick them from wherever it's best usable for you. It's easier for you. All right. So we've gone through that 4th lap. Let's go back to our instructions. Well, that was the major pit stop. I think I've left a few time for you to build the pipelines. I think we can move on without that major pit stop. All right, you don't really need to wait for the pipelines to run. That should be okay. All right. So from there, we are going to see the child pipelines, or I should say the downstream pipelines, actually. Let's see together why I'm using downstream term rather than child. So far, we have demonstrated the capacity of GitLab to include security scans, and so the execs are amazed at what we have done so far. But the security team wanna play a role here, and they say, okay, this is great, you have done a good job, but we can do more than you. We know more security than you do. So please give us the opportunity to build our own pipeline regarding security, our own templates, and reuse them. Say, okay, we are not going to use templates here. I would like to prevent my pipelines, my main pipeline, to run forever. We're going to start a downstream pipeline, a new pipeline inside my main pipeline. This is what we're going to do now. So the security team has the ownership of the security pipeline. It will run inside my pipeline without having my main pipeline standing for hours. All right. Basically, I'm saying hours because this is truly the case. When you're doing SAST scanning, like we have done, you have seen it may run in a couple of minutes only. When you are doing DAST, so dynamic application security testing, you may want to run some attacks against your review environment for hours to see how your environment resists the attack, okay, how it behaves under the load and things like this. So maybe you want to have a child pipeline here running all your DAST things while your main pipeline is doing the SAST, which is going very fast. And so you can provide the result to your developers very fast, while the DAST will give results later on. All right. So what is a downstream pipeline? It's basically a way to enable multi-pipeline inside a single pipeline. So I've got a main pipeline, and I can then trigger other pipelines from that pipeline, from that main pipeline. And as I said, I can give there the ownership. There is a file called count owners in GitLab, which allows you to give the right of modification, basically the edit rights on a given file to a set of people. So basically here I would say my security team is the owner of my security pipeline. They are the only one who can modify it. And I just need to add this in my main pipeline, and nobody can change the behavior of the security, nobody except the security team. All right. And what I said also is that the result of the child pipeline may or may not, depending on what kind of downstream pipeline I'm using and how I set up it may or may not block the main pipeline. And so my main pipeline may wait for the child pipeline to finish, or may just finish and leave the downstream pipeline running forever. Okay, so we've got the parent-child pipeline, which is the most obvious. These are the pipelines running inside your main pipeline. So you have seen many pipelines running today, and we will see a child pipeline in a couple of minutes. Basically, another pipeline is triggered on the exact same commit. All right, it reused everything from your environment. You can have the variables flowing from the main pipeline to the child pipeline. Okay, and by default, the child pipeline lives its own life. So the main pipeline will finish, do whatever jobs it has, and like this, and the child pipeline will continue running until it ends. If you want to have a dependency between the child and the parent, you will have to use the strategy depend keyword. All right. And because this is a very, very powerful way of building pipelines, it might become very complicated as well. Okay, you can have a lot of dependencies and things, and we have limited to 2 nested levels. So you can have your main pipeline, your child pipeline, and your grandchild pipeline, and you can't go below that because otherwise it would be a nightmare to maintain. So we have limited to only 2 nested levels. The other kind of downstream pipeline is the multi-project pipeline, where your pipeline will simply trigger a pipeline in another project. Okay, in that case, there is no limits. So you can trigger from one project to another one and have tens of projects being triggered like this. Okay, but when you are doing this, there is no way for your first pipeline to wait for the other ones. So there is no dependency here. You're triggering the other project pipeline and they are running their own life. All right. And as well, they are not running on the same code because they are running on another project or a different commit SHA and so on and so forth. All right. Let's remove that. Okay, and from there, you can mix things. We have seen that I've shown you the rules. So you know how to define rules to consider running your jobs in certain cases and not other cases. And you can add the rules as well on your jobs to determine if a job is being triggered as a child pipeline or from a merge request, from a commit, from wherever. But you can also know that you're running in a subsequent in a downstream pipeline. All right. So here, what we are doing is the job one will display will echo that it runs in a child pipeline. The job two will run only on the main pipeline, and the job three will run in both the main pipeline and the triggered pipeline downstream. Okay, you know the basics of the child pipelines. So let's move on and follow the instruction in this last lap that we're going to run together. Let's move on to the courses. I'll go back to my instructions here. Lap 5, child pipeline. Okay, so here what we are going to do basically is we are going to revert a little bit what we have done in the previous in the previous instruction set in the previous lap. We have added the security to the main pipeline. What we're going to do is to remove them from the main pipeline and add them to a downstream pipeline. So basically, we are going to include that downstream pipeline and trigger it from the main pipeline without running the security scan in the main pipeline. Okay, so first you will prepare the child pipeline, then you will trigger it from your main pipeline. This is basically what we're going to do right now. And like I did earlier for the fourth lap, I leave you the floor so you can experience it by yourself. Go ahead and we'll go through it in a couple of minutes together. Right. And like I said earlier, just add a thumbs up in the chat so I know when most of you have already finished. Thank you. Enjoy. All right. I've seen a lot of thumbs ups. You are doing a great job. Congrats. Let's move on together. This one finished. You can follow up with me. So, step one, preparing the child pipeline. Your security team got wind of all the security scanning you've added to your pipeline, and I understand them, to be honest, and wants it to be added to a new pipeline that they have access to and can control which jobs are run. All right, we're going to create a child pipeline, and we're going to link that child pipeline to the existing one. Okay, to do so, we are first going to edit our project and create a folder named security pipeline. So here we're going to use the web ID. Obviously, you can do it in wherever ID, whatever ID you want to use, locally, remotely, using Gitpod. Well, use whatever is best for you, but it's really easy to use the web ID actually. If you have a small modification to do, just click on the edit button, click on web IDE, and here you have a VS code, which is popping up for you, which is already on the branch that you want to modify. Okay, so you're really good to go here. Let's, can I zoom in a little bit maybe? No, not too wide. Okay, it should be good. Let me know if it's not big enough. Okay, so here we are going to create a folder. We'll name it security pipeline, and I'm really just copy paste that security pipeline. Okay, and in there I will create a file named security GitLab YAML. No problem. Creating a file, security GitLab YAML file. All right, and in that file I will just copy paste basically the include templates that I used to have in my main pipeline, the one that we have included in the previous lab. All right, the code quality, dependency scanning, SAST, secret detection. I would just want to talk a little bit about that one. That one is just amazing for me. The secret detection detects your secrets when you are leaking them. So if you are maybe copy paste, if you copy paste your GitLab token, for example, you want to run some tests locally and you need your token, you're pasting them in a file for convenience. And unfortunately, you're just committing them. GitLab is able to detect that and is even able to cancel your token for you automatically. It can do the same with the with your cloud keys, okay, your private keys that you are using to access GCP, AWS, whatever. Okay, we can detect that you have committed them, and we can even automate the cancellation. So this tool is really great, and running that on your code base, you would be amazed by the number of secrets that are living their own life in your code base. This is a real tool, a very useful tool for me. Okay. Then go back to the instruction, going back to the instruction. So now we have everything that we need to run our security test. Once added, click on the commit and push. All right, no problem. This is the commit button here, and added security pipeline, right? And this is stage 5, added 5.1. Okay, added security pipeline. I'm committing that. All right. And now I will just close that and go back here to my main project. And I will go back to the pipeline editor. Of course, I could have edited the pipeline directly from the web ID as well. No problem with that. So from there, I want to remove a couple of things, and I will just reuse that base pipeline here. I'm going to copy and paste that. If you don't want to copy paste, you simply have to remove everything that we have included in Lab 4. So it includes these things, changing it on the stage and so on and so forth. I'm lazy, so I'm just copying and pasting. All right, I've got everything here, and from that base, I will add an extra security stage. Just copy and paste that to my stage. All right. Once again, I'm not very good in copy pasting. I will talk about the container scanning. I will have a short talk about that one. Okay, and I will add a downstream security job. Okay, so let's do that together and look at what we are doing here. What are we doing? Here, I'm defining a new job. This is how we define job, like the build, super fast test, and so on and so forth. Okay, no problem. Then I'm setting it to a specific state that I've defined it above. And then I'm using that trigger keyword. Indentation is not very good here. Sorry about that. Okay, the trigger keyword, which is the one that we use to trigger a new pipeline, a downstream pipeline. And I will include a local file, which is in my security pipeline, security GitLab YAML file, the one that I have committed a couple of seconds ago, actually. All right, so this is the way I will include a new pipeline in my pipeline, a downstream pipeline. All right, and if I'm not really understanding, all right, no, that's okay. All right, so let's add that. I see numbers 5.02, I guess. Added downstream pipeline, right? And I'm committing the changes here. Okay, going back to the code. Clicking my breadcrumb here. Okay, and the pipeline has started. I can see it here. Let's see what's going on. I've got my build, my test, my extra security. These are my 3 stages. All right. I haven't added any needs on the extra security, so it will wait for the build and test actually for the test to have finished. It has dependency on the previous stage. And once it will have finished, it will trigger something here. In the meantime, let's talk about the container scanning that we have seen in the previous pipeline while this one is running. Where was it? Here, I guess. Yeah, it was here. So we have seen, oh no, no container scanning running here. I don't have a container even here. Well, the container scanner is included in my pipeline, but since I don't have any Docker file, it's not triggered. So you don't see the jobs which I've run. The container scanning is our tools to scan your container, so basically your Docker file. And we will check if there is any failure, any threat in your Docker file, and not only in your Docker file, but also in the parent file. So basically from instruction, in your Docker file, and we check if there is anything in your base images that is a problem for your assets. And yes, we rely on 3D. All right. So now my pipeline is still running. So I will show you why it's running. I will show you another thing. I said earlier, AI is everywhere, and that's true. I mean, maybe you want to understand what's going on a piece of code, that one, for example. I can select any piece of code, that one, whatever. Okay, and click on that little question mark here on the left side, and have the AI explaining me the code. So I know here what this piece of code is going to do. It's going to log into Docker, build image, produce image, and so on and so forth, and save the gem file log. Okay, this is an explanation which makes the code understandable, say, and it may help you to feel more confident when you want to change something, when you need to update the code, when you have some maintenance to do. You haven't wrote this code, it's a legacy code, and the AI can help you feel more comfortable and get ready to modify things without breaking everything. All right. Let's see if our pipeline has finished. Maybe if you are interested in the AI and if this is something that is relevant to you, please check our workshops. We have some workshops coming on for the AI dedicated to AI, and you may be interested as well to understand what we are doing with AI and how we can help you globally in your daily life, I would say. And so back to our pipeline here, I've got my build test, they are finished. So my exploratory stage has started, and here we can see the downstream pipeline that I can expand here and see all the stages and all the jobs in my stages for this specific downstream pipeline. Okay, so here I only have the test stage with a lot of jobs running, all the ones that used to run in my previous job. So this has been triggered in the downstream pipeline. All right. And this is still running while we can see the pipeline here is finished. It's not running, it's finished. It's warning because one of the jobs has failed. This is the super fast, which has failed. But here we are not in the running phase because we do not added any dependency from the main pipeline to the downstream pipeline. Okay, so this is why we have the status here, which says my pipeline is finished. This one could last for hours. It won't be a problem. My pipeline, my main pipeline is finished. All right. So what have we covered? Oops. Come on. Yeah. What have we covered so far before transferring the project? Yeah. Let's recap what we have seen so far. We have started a pipeline, starting from scratch for everyone to be ready to go and have the basic understanding. Then we have seen how we can order the things and create a graph, a dependency and graph between all our jobs to have them execute as fast as we want and to link them the way we want them to be linked. Then we have seen how we can add some cache to make the subsequent pipelines or the next jobs running faster using data shared from one job to the other or from one pipeline to the other. We have also seen how we can handle the globally how we want the jobs to be executed, setting some rules and executing in very specific cases some jobs and not executing other in other specific cases. Or we can allow failure, basically. This makes sense if you're relying on a tool or something and you don't want your whole pipeline to fail just because the linting has failed or something like this. So you may want to allow failures while still seeing that there is a warning on the pipeline page, all right? And then we have seen how we can share things. We're reusing the templates, defining templates, reusing them, leveraging GitLab's template, which are providing you the best-in-class model to scan your code and do much more than just security. Well, even if security is and should be a masterpiece of any pipeline. All right, we have also seen how we can expose artifacts so they can be retrieved by human, basically by you, if you wanna check the JSON result of whatever of your jobs. And then we have seen the last step, how to build complex pipeline, adding child pipeline, triggering pipelines from one pipeline triggering other pipelines. One thing I haven't talked about here is that you can even imagine creating your downstream definition in the main pipeline. So it allows you to be very dynamic, basically in a single repository project. You know, when you have everything in a main project monorepo, you may want to build and trigger pipelines, different pipelines based on whether it's the front that you have modified or the backend or whatever. So if you have a monorepo, it makes sense, a lot of sense to use child pipelines, as well as if you want to deploy to different environments, you may want to leverage the usage of child pipelines. Okay, and so now that you have a clear understanding of anything that you can do in the GitLab pipeline, you want to probably go further and do a lot more because obviously there is tons of things that you can do with a GitLab pipeline, but you know have the basics to do some advanced tricks with your pipelines. We are going to move on to the last step, which is the transfer project. I would advise you to not run it now because basically the idea here is to get the transfer back from the environment that we have provided to you today to your own space. All right, and in your own space, maybe you don't have GitLab Ultimate, maybe you don't have access to all the features, you don't have access to AI. Basically, we have provided all of these things to you in the in this workshop. So please enjoy the workshop area for the next 48 hours. Do whatever you want, experience with the AI, experience, go further with the CI/CD things and whatever you need with your pipelines. And within 48 hours, just transfer the project to keep a track of what you have done so far, because this environment will be deleted after that. Okay. Yeah. You will lose everything. This is what I've said. Okay, we have been through all the steps. The workshop environment will be deleted in 48 hours. So just go back to your projects and see the instruction in the transfer page. If I'm going back here, workshops, courses, sorry, Tanuki Racing courses. So let's go back to the main project. From my project here, I'm going to the courses folder, then transfer project, and you will find all the instructions that you will need to follow in the next 48 hours to get this project back in your own environment, in your own namespace, so you can still see what you have done and refer it back in a couple of days, months, years, whatever. Right. And we have reached the end of this session. You have been amazing. So we are 30 minutes ahead of time. So, well, if you still have some questions, we are here to answer us. Feel free to join to ask them in the Q&A like you have done so far. Thank you for doing this in the Q&A like you have done. It was very good. It's way harder to track that in chats. Thank you all, and thank you, Ted, Mitchell, and Logan for the first part of the presentation, for the support and everything you've done so far, and others, Elena and Marcus, for organizing this. A lot.